Hi guys, so we have this question on kinematics which reads: a particle initially at rest starts moving in a straight line with an acceleration 8 plus 12t meters per second. Find the distance covered by it in 3 seconds. So we have the second part as well. So what I'm going to do is this: let's do them in 2 separate parts so that we can see how we can calculate what is required. So let's start with the first part. Alright, so given the acceleration, how do we find the distance covered by it in 3 seconds? So we need to understand this. You can be given 3 things: either position or displacement, velocity, or acceleration with respect to time. So if you have displacement and you want an expression for velocity, you have to apply some calculus by differentiating. If you have velocity and you want acceleration, same thing, we differentiate. Then the reverse is integration. So in this case, in our question, we've been given an expression of acceleration, which is 8 plus 12t. So to find the distance, we first have to move from distance to velocity and velocity to distance, or displacement in this case. So we can consider it as an expression of acceleration being integrated to get velocity. So let's integrate. So the integral of acceleration with respect to time gives us an expression for velocity. So the integral, the expression for acceleration is 8 plus 12t with respect to time. If we integrate this, we'll say 8t divided by, it's supposed to be divided by 1, plus this will be 12t squared divided by 2. That's integration. So let's see what we get. This gives us 8t plus 6t squared. Now, this is an expression for velocity. Since we have velocity, now we can find the distance. Remember, if you have velocity, to find distance or displacement, we have to integrate again. So the integral of velocity with respect to time will give us distance or displacement. So let's integrate velocity. We have 8t plus 6t squared with respect to t. That's the velocity. Integrating 8t gives us 8t squared over 2. Integrating 6t squared gives us 6t to the power 3 over 3. But now, let's apply the limits. Remember, we have limits from rest. So rest, we mean time is 0, all the way up to time is 3 seconds. So in this case, for this particular integral, we can just say it starts from rest all the way up to 3. So this has limits from 0 to 3. So this expression becomes 4t squared plus 2t cubed. With limits from 0 to 3. Let's apply the limits. If I replace t with the upper limit, which is 3, this is what I'll get. So the distance, let's just use x. Distance x will be equals to, so 4, where there's t, I'll replace it with the upper limit, which is 3, plus, again, where there's t, upper limit, which is 3. This is supposed to be squared. Okay. Then minus, again, where there's t in that expression, I'll just replace it with a 0 and a 0. So that's what we get. So x will be equals to 4, 3 squared is simply 9, plus 2 times, 2 times 27. 3 cubed is 27. Okay. So adding the 2, let's see what we get. 4 times 9 will give us 36, of course, and 36 plus 54 should give us a 90. So that's our distance. Distance here is 90 meters. There we have it. That's how we find it. A body with initial velocity 8 meters per second moves along a straight line with a constant acceleration. and travels 640 meters in 40 seconds. For the 40 seconds interval, calculate the average velocity. Okay. So average velocity, let's just consider the total time taken and the total displacement taken. So the displacement or the distance, in this case, is 640. Total time is 40 seconds. Okay, so if we divide what we have, this should give us 16 meters per second. Part B says the final velocity. So to find the final velocity, we'll say final velocity is equals to, since we don't have acceleration, let's use this formula. Initial velocity plus 80. Okay, but remember we don't have acceleration. So before we even find the final velocity, we need to obtain an expression for acceleration. So to do that, we'll say acceleration can be obtained from this formula. X is equals to ut plus half at squared. Right? So x is equals to, what's the initial velocity? Initial velocity is 8. Time taken is 40. Plus half a. We don't know what a is, but time here is 40. Alright, we have x. So x is 640. Then 8 times 4. This should give us 320. Plus 40 squared is 1,600. Then we divide it by 2. Which should give us 800. So this will give us 800 A. So 640 minus 320 is equals to 800 A. So let's see what we obtain. On the left hand side, we have 320 is equals to 800 A. This gives us an acceleration of 0.4. So acceleration A is 0.4 meters per second squared. Okay. So now that we have the acceleration, we can find the final velocity. So final velocity in this case will be equals to, initial velocity is 8, acceleration is 0.4, and time is 40. So 40 times 0.4 plus 8, 24. So the final velocity is 24 meters per second. Part C says find the acceleration, but we already have the acceleration. We calculated it. Acceleration is this value that we have here. So acceleration is 0.4 meters per second squared. So there we have it. I hope it makes sense.